Let me get my numbers up here. Alrighty, before we go, let's review, just so tangent goes smooth here. Cosine of an angle. In this unit, you're responsible for two, I don't want to say formulas, but two ways of finding cosine. Two ways of finding cosine. Give me one of the ways we find cosine. Two? No two? Oh, hi. How do I find cosine? There's one way, using SOHCAHTOA, adjacent over hypotenuse. Or, here's a hint, if I'm on the unit circle, I can't use adjacent over hypotenuse. If I'm on the unit circle, I'm forced to use 6. If I'm on the unit circle, I got a point on the unit circle. Give you more clues. Which one do I take? Or, Timmy, just we're one right behind you. Just grab one and let's get going. What do you got, Ryan? Which chord? Like if I say, all right, at 30 degrees, radical 3 over 2, 1/2, but I want cosine. Why? Because it's the what coordinate? There you go. So there's the two ways to find cosine. Adjacent over hypotenuse if I have a right triangle, or if I'm on the unit circle, I take the x coordinate. All right, what about sine? Tell me the two different ways I could find the sine of an angle. Two different ways. First way, we're going to go different here. 4, opposite over hypotenuse if I have a right triangle. If I don't, if I'm on the unit circle, I'm going to use the 10 y coordinate. All right, everyone good? All right, now let's introduce tangent, the third one you know of. What if I have a right triangle? You guys remember this? Opposite over adjacent, right? TOA, T-O-A, opposite over adjacent. Ooh, ready for this? What if you're on the unit circle? I ran out of points, didn't I? I can't take the x or the y. They belong to sine and cosine. I'm running out. So if you're on the unit circle, it's equal to the sine over the cosine. So help me fill this out. Sine over cosine is tangent. So 6, what's the sine coordinate again? And what's the cosine coordinate? There you go. So that, hey, everyone, that's how you find tangent on the unit circle. Take the y coordinate, divide it by the x coordinate. Are we all right? All right, now, where's everything positive and negative? So let's go to each quadrant and say, this is positive, this is positive, this is positive, this is positive. Anybody remember the way to remember that? The 4 letters you put in here? What are the 4 letters? Dylan?
All students take classes.
All students take classes. All sine, tangent, cosine. All right, so help me fill in my chart right now. In the first quadrant, what's positive? In the first quadrant, what's positive? 1, what's positive in the first? Anything else? What's the A mean? Okay. Including our new one here today, tangent. Second quadrant. Let's go under quad 2. Where's the plus sign going to be here? Where's the positive one here? 13?
Well, cosine would be negative.
Okay, yep, good. Negative. What about the rest?
Oh, the rest is they're both positive.
What's the S in quad 2 mean? S stands for?
Oh, sine.
That means only sine. Everything else, negative. Everything else, negative in the second. All right, tell me something about the third. 8, tell me something about the third. What's positive there?
Tangent is positive.
Yep.
And the rest are negative.
Rest, boom, boom, negative. Only tangent in the third. And then finally, tell me something about the fourth quadrant. 3.
Cosine's positive.
And the rest? Yep. See how this works now. All right, see how these letters work? All right, I want to keep doing problems we've been doing, but now ask you about a tangent. All right, go ahead. You can read through number 2. Read through number 2. What quadrant are we in? What quadrant are we in? Second. So what do I need to make in the second quadrant? Sine is 5 over 13. What are you guys building in the second quadrant? From our work the last couple days, what are you making in the second quadrant? A right triangle. And remember, if you're unsure how to make it, draw the bow tie. Right triangle in the second quadrant. Remember the angle you always use, the reference angle, the one closest to the origin here. This one right here, your reference angle on the x-axis. That's the angle we always use. All right, we were given sine 5 over 13. So can you guys, as I walk around here, where should that 5 go? And where should that 13 go on the triangle? If it's sine is 5 over 13. You see where the angle is. So where should your 5 and your 13 go? Sine, think about what sine's equal to. Put the 5 and the 13 corresponding to it. Some of you are getting ahead of the game. Opposite over hypotenuse. So you got to go opposite to put the 5, hypotenuse 13, and you guys have already, a lot of you guys figured out already, you're going to need that third side. How? How am I going to find that third side? 10? Pythag, go ahead. 5 squared. What do I put next, 13 or B? B squared. All right, go ahead, find B. All right, what'd you find that third side as? 3, third side.
12.
12, good work, Dylan. So that's 12.
Wouldn't it be negative?
You could put a negative there if you wanted to. Or what I'm going to do is we got to remember that when we find the rest here. All right, determine the value of cosine. Ready? I have a right triangle, so how do you find cosine? How do we find cosine on a right triangle? 14?
A over H.
A over H. Can somebody give me the adjacent and the hypotenuse? Remember where we're going from, this angle right here. What is the adjacent hypotenuse? 2? Okay, 12 over 13. Now, again, I cringe every time because this is where you got to be on top of your game. What quadrant am I in? 2, and I found cosine. What should I know about my answer? Should be negative. All right. So whether you put it at the beginning, Aaron, like you were telling me to do, or you remember it at the end. Find tangent. All right, next one. Find tan theta. How do you find tangent on a right triangle? 6, tangent on a right triangle. All right, you got me there. I could do that. I want to get to it a little quicker. How about using opposites, adjacents, and hypotenuses instead? Tangent. Opposite over adjacent. How do you find that? Which one is opposite and adjacent here? 3. Opposite and adjacent, Dylan?
5 or negative 5.
Good. Why negative?
Because the only positive is sin.
Sin. It's a sin to say that. Sine.
Sine. Yeah, that's right. Sorry.
Everyone good? Tangent's negative in the second, so that's why I put a negative. And then the last question is, what is the angle? All right, so think, what quad are we in? 2. So it's got to be between what 2 degree measures? 90 and 180. So it's got to be between 90 and 180. Last time we did this, I had you guys take an inverse on the calculator, right? You did the second button, but I told you what? Pick the one that has because I have 3 options. I could go inverse sine, cosine, or tangent, but I prefer one over the other 2. One that's positive. And out of those 3, which one has a positive answer? The sine. So I prefer you take inverse sine. So theta is going to be inverse sine. What was it? 5 over 13. Use the one that's positive. And remember, your calculator does not know what quadrant you're in. So what's it always going to give you back? Which is what here? 23? Okay, so it's giving you, your calculator has no idea what quad you're in. So it's just going to say, here's the reference angle. All right, now use that reference angle, 23 degrees, to get it in quad 2. See what you can do. So how do I use 23 to get an angle in the quadrant 2? 5?
You subtract 180.
And?
23.
Yep. And what's that? 157. There you go. So anytime it asks you to find theta, do the inverse of whatever is positive. And it's going to give you the reference angle back. All right. Questions, comments? We're sure. All right, so this is using a right triangle. What if I'm on the unit circle now? All right, use the unit circle to find these tangents. Tangent 45, anybody want to tell me? 45, we're on the unit circle, anybody? 45 on the unit circle, where are we? 6? Yep, and? Got it, here we go. Now you want tangent. So it's not just x, it's just not y. Go back and look if you need to. What's tangent equal to on the unit circle? 8?
Sine over cosine.
Sine over cosine, so the what coordinate over what? Keep going with me, Nora, good job.
Y over.
Y over x, everyone. So take the y coordinate, divide it by the x coordinate. And this is going to look funky, so we got to go back to Algebra 2A last year and learn how to correct this. So the y coordinate, radical 2 over 2, put it on top. Divided by the x coordinate, radical 2 over 2, put it on the bottom. Okay, this is what's called a complex fraction, and you can't leave your answers like this. No, that looks disgusting, right? Remember our good old skip and flip days? That's what this is. Keep the numerator the same. So keep it the same, radical 2 over 2. Remember to do what to the bottom one? Flip it. 2 over radical 2. And then what's the new operation now? Not division, but multiplication. Yep, so that's what we're doing here when I have a fraction over a fraction. Anything you can cross out? Tops and bottoms? 2's? And the square root of 2's go. So what's the answer? 0? 1. Yep. So the tangent of 45 is 1. And you could confirm that on your calculator. Tangent of 45 is 1. All right, next up. Good, Jared?
Yeah.
Okay. I'm going to kind of take this one off and have you guys take the lead. Tangent 150. And I know everyone, go to my calculator, and then what's in your face? A sloppy decimal, which we cannot write down as an answer. No credit whatsoever. So where do you start? Where do we start here? Tan of 150. Where do I even go? You got something? I need to know what's the deal here. Am I at 30? Am I at 45? Am I at 60? I got to find the reference angle. So what is the reference angle for 150? 30. Correct. So now I start thinking about the point at 30. What's my point at 30? Square root of 3 over 2, 1/2. Tangent. Y, 1/2, divided by the x, radical 3 over 2. What do I do to the 1/2? Keep. Flip the 2 over, flip the radical 3 over 2 and change it to?
2 over radical 3. And then flip the
Oh, don't here. Oh yeah, I'm glad some of you are bringing that up. Don't, if you have a radical in your denominator, that's only a bad thing unless it's in your final answer. So just leave this like this for now. Okay, don't try to convert it right now. Just do your thing, multiply them. And what cancels out?
2.
Yeah. Wait till the end if you have to. Wait till the end. And speaking of that, what's left on top?
1
Over.
radical 3.
That's a problem, right? No self-respect. We fix it by
Radical and multiply it by radical 3 over radical 3.
whoa. So what do I end up with here?
1 over radical.
1
1 radical 3 over
Yep.
3.
over 3. And I got to get you into this habit. Check your answer. Check it. Everyone type in tan of 150 with me. Tan of 150. Do you notice something different right away? Yeah. And hey, if you check it, it's okay if you forgot it. Anybody know why it has to be negative? Quad. What quad am I in? 2. Tangent's negative. Right? But hey, that's okay if you forget. Just check the darn thing real quick on your calculator. Oh, geez, I forgot the negative sign. And then do radical 3 over 3, and hopefully it matches your answer that you got for tan of 150. All right? Tan 180. Anybody remember my advice yesterday? If it's on the line?
Use the x and y.
You could. I don't want to have to go through all that. Maybe I didn't tell you yesterday. If it's like 90, 180, 270, and you got to find sine, cosine, and now tangent, just use your calculator. Your calculator, these answers on the line will never be decimals. So I'm just going to suggest use your calculator, make life easy. You don't have to remember the points there. Dylan?
Sorry, I have a question.
Yep.
So, you don't, so technically, like, you're finding the reference angle, right? But that's just the same if it's, like...
There is no
anywhere.
reference angle for 180 because it's on the line.
Oh, no, I mean for the last one.
Yeah, yep, you're finding the reference angle,
Okay.
which is 30. But the actual angle we're finding is 150.
Oh, wait, so that's why...
That's why it's negative.
So the sine is the only thing like that. Really?
Correct.
Okay.
Yes. All right. So what'd you guys find? Tangent of 180? 0. So everyone good? If it's ever on the line, don't bother going through, oh, what's the coordinate again? I'm just going to make life easy. It's 0. Everyone good? All right. Next one. Just wanted to show you something because tangent's got a special quality to it. Here's my angle, 90, right? Or pi over 2 in radians, 90 degrees. What's the sine and cosine of this angle? So I'm asking for what's the sine of 90 and what's the cosine of 90? That's what I'm asking here. We just went over this, right? If you're asked to find sine, cosine, tangent of any of the quadrantal ones, plug them in. Instead of trying to go to the unit circle, remember the coordinates. Which coordinate do I pick off? Sine of 90?
1.
Should be 1.
I haven't flipped.
Sine of, well, maybe you did cosine.
I don't know.
Oh, it's fine. Sine of 90 is 1. Cosine of 90? 0. Now watch this. And we'll talk why. What about tangent of 90?
Undefined.
Everyone getting an error message?
Yeah.
There is no value. Here's why. Ready? Here's why. Remember, tangent is what coordinate over what coordinate?
Y over X.
What's the sign over here? Or the y coordinate?
1.
1 over.
0.
Can you ever divide by 0? That's why your calculator is giving you that error message. So when you do tangent of 90, there is no answer, undefined. There is no value at tangent of 90. It's undefined. And there's also another one that's undefined, and that's what you guys are going to find in number 5. Which other angle other than 90 gives you an undefined tangent value? And what else gives you an undefined value? 270, yep. So as you're doing the assignment, if you're doing a right triangle, opposite over adjacent. If you're doing unit circle, y over x. Okay, on the unit circle, the y over the x. Go ahead, get going. Chromebooks out. Come on, get those answer keys open. I think it's day what, 12, 13?